Hey guys, Aubrey here with Erie Motorsports. Today I'm working on making a new pulley for my power steering pump. If you saw my previous video, I went from a gear-driven power steering pump. I pulled that out. I'm going to cut the timing cover so that the timing gear cover so that I can set my mower lower in the chassis. But I went to a belt-driven power steering pump from Radial Dynamics, and um, it's working good, but it's not spinning fast enough. And so I need a smaller pulley because I want my steering to be more responsive. At low RPM, really struggles when you get into the rocks at low RPM. You have to make quick turns around trees and stuff, and it just is really struggling to move as fast as I want it to. So I talked to Eric, Radial Dynamics. He sent me a higher flow outlet for that power steering pump, and I put it in there, and it's closer to where I want it, but I want it to go a little bit faster yet. And these pumps are made to go on vehicles that are running, 6, 7, 8,000 RPM at peak, and I'm not getting anywhere near that. Like maximums like 32, maybe 35, but the motor really falls on its face anything over 3,000. So I'm keeping it pretty low RPM most of the time, especially in the woods races and in the trees and stuff like that. So I want to make a smaller pulley for it so I can overdrive it. Um, this is a pulley from Innovators West. The thing is that there are not very many pulley options for your 8-rib belts. Most of the pulley options are for 6-rib belts. So when you get into the 8-rib, it can be really tough to find what you're looking for. This one is not cheap. I think they're like 150 bucks, but my new one's going to cost me more because I had to buy tooling for it. So it comes with this hub, the 1080-2 hub from Innovators West. I don't know if this is a common hub or not, but so I'm going to make a new aluminum piece that'll go on here. Now I have a insert and bit holder from Tool Flow here that'll do 4 ribs at a time. Now for the 8-rib belts, this is a Poly V cutter, and it's a 140 thousandths pitch between these. So it's pretty easy. You're just gonna stick it in there straight and then move it over 140 thousandths times 4, which is what, 560 thousandths. And go in again. Now, one thing that I did was I would cut a little bit 5 thousandths off to one side and 5 thousandths to the other side, so it got a little bit less chatter because it was riding one edge instead of the other, instead of just going straight in. And you can see I had to modify this a little bit. Now, this Tool Flow holder is about 150 bucks, and the inserts are about 50 bucks. The only problem is that you can't get these inserts individual. They only sell them in 10 packs. So it's really frustrating. I couldn't find any place that would sell me an individual one. So I actually ended up buying a 10 pack and then listing the other ones on eBay. Hopefully some people buy them off of me and I'll be able to, not have that much money out into them. But I figured I wanted to have the tooling so I can make these in the future. I might have to mess around with pulley sizes. So I'm going to go ahead and start machining this, and then I'll show you the results.
I had two major issues that happened when I was turning this piece. One was that it caught pretty bad here, and you'll see it in a second. But it caught because for two reasons. One, that my workpiece was so long and it was sticking so far out of my chuck, and the second reason is that my tool post was out very close to the edge of my top slide where it was able to flex it just a little bit. So it bent my the bolt that holds my tool post in place, and it messed up my piece a little bit, but I was able to cut it off of there and get it straightened back out. The other major issue that I had was when I was turning this piece and cutting the grooves, it was getting way too hot, and at one point it actually galled up pretty bad and messed up my ribs again. So I had to machine it down just a little bit smaller than I wanted to, but it's still, pretty close. It's only maybe a 16th of an inch smaller in diameter than what I was aiming for. All in all, it went pretty well, and I didn't have any, catastrophic failures.
All right, so here's the finished product. Came out pretty decent. I had it catch once or twice, and had to make it just slightly smaller than I wanted to. So we'll see how it runs. If it runs too hot, I will consider um, making a slightly larger one. But now I know how to do it. I also gave a little bit more backspace here because I actually had to put washers on the back of my power steering pump to get it where I wanted it because it was off slightly. So now it'll be right on. Um, this fits in here quite nicely. So really nice tight fit. Um, and then I've got to get these holes. Now, I'm not gonna, I don't have a CNC machine that's gonna punch these right out in the perfect order, and I don't have a indexer that will, put it in my milling machine or anything fancy like that. So what I'm gonna do is I'm going to take this bolt and put a nut on there so it's nice and straight, and put it in my lathe and drill a hole right down the center of it. Then I'm going to pull the nut off. The nut's just for alignment in the lathe, so you keep it nice and straight. I'm going to pull the nut off and insert it into here and clamp this in place and use this as a drill guide. So I can drill out each one of these holes with a pilot hole, and then I will drill it to the size that I need. It shouldn't really matter too much. I mean, these could be pretty sloppy because what's important is that it's on here. But I still want them to be nice and accurate. So this should get them pretty accurate without any fancy tooling or being too time consuming.
Oh, there we go.
All right, so real quick, I got this that piece all ready to go, and I'm just going to take this and bolt it. I got a spacer in here. This piece sticks through a little bit there, so I got this little spacer in there, and just some crap that I had laying around. So I'm going to bolt this really nice and tight here. And that's going to keep this from moving and give me access to all of these holes so I don't have to clamp or move the clamp around while I'm trying to get this done. So we'll go ahead and get this drilled out now. Yeah, I don't know if you can see it here. See if I can get this lined up. But all my holes are nice and dead center. Now I just have to slap it in my mill and line them up and drill them out. All right, so this is all wrapped up, good to go. The holes align really well. Um, so I've already got a hub on there, so all I got to do is unscrew uh, this pulley and pop a new one on there. And I got to swap out the brakes real quick while I got it up in the air. So I'll get that done and test it out and let you know how it is.
Keep going.
All right, so I just took it out, did some testing with it, and I'm really happy with where it's at now. I would say that putting that higher flow outlet port on it made a bigger difference than downsizing the pulley. But both things helped a lot, and the pulley that was on there was already pretty small, so I was really hoping that I wasn't going to have to go to a trophy truck pump because that's like a $2,000 pump, and so this one's going to work really well. This is the TC pump from Radial Dynamics. And if you run the setup like mine on a Cummins, you can run the smaller pulley and the higher flow outlet port. If you're putting it on a race car engine where it's going to be turning 6, 7, 8,000 RPM, you can't do that. So I hope this video was helpful, informative, and please like and subscribe for more video and content. Thanks.